already studied in detail the relation from R such that A to B. The only condition required for a relation is that R should be a subset of A cross B. If you write in roster form and AB is an element of relation, you know the only requirement is that A should belong to first set, A, and B to the second set. Now, some particular relations are functions. This already you have done in class 11. So before starting the new topic, that is type of functions, let me revise with you what do you mean by function. Before formally defining formal mathematical definition of function, let us see a situation just for revision. Consider A as set of students. Set of students, say A, B, C, D, E, F. A, B, C, D, E, F. Capital A is set of students A, B, C, D, E, F. And B is the set of hostel rooms. Set of rooms in a hostel consisting of say 7 rooms, room number 1, 2, 3, 4, 5, 6, 7. And remember, it is a residential school. Away from your own home. So what is there in a residential school? That every student needs to be accommodated in one room or the other in the hostel. Maybe all the students sometimes, if rooms are not vacant, may be accommodated in a single hall. Okay. Now see the different situation. Let me call it F1. F stands for function. Already you have done this. Look at this. Student A is allotted room number 1. Student B is allotted room number 2. C is allotted room number D. C is also allotted room number 2. D is allotted room number 3. E is allotted room number 4. And F is required to stay in room number 7. That way, room number 5 and 6 are still vacant. Is it a go-go situation? Will it work? See, all the students A, B, C, D, E, F have been allotted some room or the other. Okay. Maybe room number 5 and 6 are still vacant. Now look at another situation. Say F2. A is the set of students, B is the set of hostel rooms, A, B, C, D, E, F, room number 1, 2, 3, 4, 5, 6, 7. Now look at this example. A is given room number 1, B is asked to stay in room number 2, C occupies room number 2, C also occupies room number 3, D goes to room number 4, E is allotted room number 5, and F is given room number 6. Of course, room number 7 is vacant. What do you say about this situation? Haji, Harji, boliye, is this right? Now, what is the problem in this? Can you tell me? What is the problem with this situation? It is a residential school. It is a hostel. A consists of students A, B, C, D, E, F, and B consists of the room numbers. Is there any problem in this allotment? What is the problem? what do you say about student C? I already says C occupies, है ना, भाग के जाके घेर लिए दो कमरे, एक में एक बैग रख दिया, एक में अपना दूसरा बैगेज रख दिया. Is this possible? Can a student occupy 2 rooms? No. There is no doubt that every student has got some accommodation, but no student can occupy more than 1 room. Because otherwise, another student will ask, hey, are you a Nawab? You will occupy more than 1 room. So this is not a possible situation. Okay, let's take one more example. F3. Set of students A, B, C, D, E, F, and room number 1, 2, 3, 4, 5, 6, 7. Look at this relation. If I say A goes to room number 1, B to room number 2, C to room number 3, D and E are also asked to share room number 3 only, and F. Yeah, this is the situation. A is allotted room number 1, B occupies room number 2, C, D and F, all of them have to share room number 3. So this is the allotment. What do you say about this allotment? Yes, Heather, what do you say? Huh? What about this F? Huh? Where will he go? Will he go back home? Or will stay outside? Overnight he will stay out. What is the problem? The problem is that student F has not been allotted any room whatsoever. In a residential school situation, this is not possible. So now you look at all the 3 cases, all the 3 relations mathematically speaking. In F1, every student has been allotted some room, as well as you find that in F1, 2 students B and C have to share a common room number 2. That is possible. As I said earlier, maybe sometimes all the students A, B, C, D, E, F are asked to share one particular hall. That is okay. Every student is been allotted some room. Remember, rooms may lie vacant. Every student has to be accommodated in one room or the other. More than one student, 2 or more students may go to one particular room. But what was the problem in second case? In second case, the problem was there should be no person here, C, who can occupy more than one. Mathematically speaking, no element of set A should be associated with more than one. That means every element can be associated to 1. And then in example 3, F3, the problem is that F has simply not been allotted any room. So what do you conclude? Can you tell me the total scenario in one line? It is that every student should be allotted a room, but it should be unique. Every and unique. You remember only 2 things. Every and unique. Each student of set A should be allotted a unique. Unique means 1, but not more than 1 room. And to such kind of relation, or the room allotments or whatever you call, will formally define functions. And now note down the definition of function. Definition. F for function such that from set A to B is a correspondence which associate to each element of set A unique. A unique. What do you mean by unique? 1 and only 1. And second thing which you should have noted earlier, that A to B is a correspondence which associates to each element. To each. I repeat, F such that A to B is a correspondence which associates to each element of set A a unique, that is one and only one element of set B. And here you find that F1, if I write F1 in set builder form, that is A1, B2, C2, D3, E4 and F7. What do you find here? That there are no two ordered pair in which the first entry is repeated. If I define the function in roster form, earlier I defined in set, in terms of sets. What do you find? A, B, C, D, E, F. There are no two ordered pair in which first entry is repeated. Though the second entry you find 2 is repeated. That means two elements B and C are associated to the same element. That is possible. Further you find that there are entries. There are room number 5 and 6 which are not associated. If you take the set of all elements, the first entry is A, B, C, D, E, F, that will be same as A. So every element of set A, each element of set A is associated to a unique element of set B. Whereas if you write F2 in roster form, just see, if you write F2 in roster form, it is A1, B2, you get C2, C3 and F6. Of course, I missed one, D4. A1, B2, C2 and C3, D4, E5, F6. What do you find here? That is the second entry, the first entry here, the C repeats because C occupies, C is associated to 2 as well as 3. It is not a function. So if you find a relation in which the first entry repeats, then it is not a function. Second thing you should check, that you take the set of first entries A, B, C, D, E, F. The set of first entries should be same as the first set A. Then only it will be a function. And in the third example, you find that the set of first entries is A, B, C, D, E, F is missing there. It is not equal to set A, so it is not a function. So here I just tried to revise the definition of function. Now when I formally defined what exactly you mean by function, let me also further explain certain terms. For example, in F1, the elements are A1, B2 and so on. That is, to student A, room number 1 is allotted. We can write it A, FA equal to 1. Or we may also write the image of A is 1. Or I may further write pre-image of an element of set B, that is pre-image of 1 is A. Please note the three terms. If element A is associated to 1 under the given function f, so we may write f A is 1. Note the symbol and the terminology. Or we may say image of A is 1. Or from set B towards A, the reverse, the pre-image of 1 is A. Now likewise, when you write B2, it may also be written as BF2. It may be written as FB equal to 2. All this gives you the same information. Or the image of inverse, image of B is 2. Or the value of the function at x is equal to B is 2. Or the pre-image of 2 is B. So I suppose now you understood the definition of function from set A to B. Then what do you mean by the value of functional value of an element of A to B? image and pre-image.